Welcome to my YouTube channel. So today I will start complex analysis. So first we discuss complex number, and the first section is the definition of complex number. So first of all, let us consider ordered pair x comma y. So here ordered pair means ordered means x y and yx are distinct unless x equal to y. So this implies that x comma y not equal to y comma x if or only if x not equal to y. So whenever x not equal to y, then these two are different. Then we said this is ordered pair. So all such ordered pair x comma y from R cross R, all such ordered xy such that x belongs to R and y also belongs to R contained in the set of complex numbers. So complex numbers we denoted by C, set of complex numbers, and it contains all the ordered pair from x belongs to R and y belongs to R. So in C, in set of complex number, we define addition and multiplication between two such pair. Such pairs x1 y1 and x2 y2 by, that is, x1 comma y1 plus x2 comma y2 is defined by simply x1 plus x2 comma y1 plus y2, and multiplication by, or just a position, that is x1 y1 into x2 y2 by x1 x2 minus y1 y2 and x1 y2 plus y1 x2. So how can we get this? This x1 y1 can be written as x1 plus I y1, where I equal to root over minus 1, and this is the imaginary part of the complex number, and x2 comma y2 can be written as x2 plus I y2, and if we add this term we get, this is real part, x1 plus y, x1 plus x2, and imaginary part as y1 plus y2. So from this addition we get this and this. This is real part and this is imaginary part, and if we multiply, then we get x1 plus I y1 into x2 plus I y2 as x1 x2 into this I minus 1. So from here I square equal to minus 1. So we get I square y1 y2, that is minus y1 y2, and plus I, and from here we get, from here this and this, so x1 y2, and from this and this we get y1 x2. So this will be the result from multiplication. So this and this. So we can say if z1 equal to x1 comma y1 and z2 equal to x2 comma y2, then we say that z1 equal to z2 if and only if, that is implies and implied by x1 equal to x2 and y1 equal to y2. So clearly this can be written as x1 plus I y1 and this can be written as x2 plus iy. So this will be equal if this real part be equal, that is x1 plus x1 equal to x2, and the imaginary part be equal. So this as simple as that. In particular, z equal to x comma y 0 0 if and only x equal to 0 and y equal to 0. So if x and y equal to 0, then z equal to 0 0. So for equivalence relation, following properties for equality of ordered pair, making and equivalence relation. What are the following properties? For z1, z2 and z3 in C, one is z1 equal to z1, two is z1 equal to z2, implies and implied by z2 equal to z1, and third one is z1 equal to z2 and z2 equal to z3, we can only z1 equal to z3. So if z1 equal to z2 and z2 equal to z3, then this will be equal z1 and z3. So this is called commutative law, and this is called associative law. So if this happen, then we say this say is in C equivalence relation occurs between pairs. Now we see that the graphical representation of complex number. A complex number z equal to x plus iy. So we can graphically represent it here. This is real of z, and this is y equal to imaginary of z. So this is real axis, that is x, and this is y, imaginary axis, real axis, imaginary axis. So x plus y can be written as this is x and this is y. So x y pair. So this is, and it can be put it as like this as a vector. So this is the length, and length can be considered as mod z, that is mod x plus I y, and that can be written as root over x square plus y square. And for this complex number z equal to x plus iy, the complex conjugate is defined as z bar, denoted by z bar, and is defined as x minus iy. So this plus the imaginary part become opposite, that is, as this is x comma y, so mirror image with respect to real axis, that is this x comma minus y becomes the conjugate of this point. So this is y and this is minus y. So this becomes x plus iy and this becomes x minus iy. So for this real number, for this complex number, the complex conjugate become like this. So from this we can calculate that x equal to z plus z bar divided by 2. So if you add these two terms, so 2x equal to z plus z bar, and then x equal to become this. So x as a real z, so we can write real z equal to z plus z bar divided by 2, and similarly imaginary z can be calculated by substitute z bar from z. So x be cancel and we get 2iy, that is 2y. So imaginary axis becomes, that is y equal to z minus z bar divided by 2. So this will be imaginary part and this will be real part. So this is to formula, and we will use to solve some problems. Sorry, if we find this, so we get 2iy, so 2iy, y imaginary part, so we get this is I. So we get real z equal to z plus z bar divided by 2, and imaginary z equal to z minus z bar divided by 2i. So also as we get that summation and multiplication, that is x1 y1 plus x2 y2 and x1 y1 into x2 y2, this is multiply, this is addition, this becomes x1 plus x2 comma y1 plus y2, and this becomes x1 x2 minus y1 y2 comma x1 y2 plus x2 y1. So from this, using this, we can find the value of I square. So as I square can be written as I into I, and I can be written as 0 plus I1, 0 plus I1. So this is x1, x2, y1, y2. And if we calculate here, x1, x2, that is 0 minus y1, y2, 1, comma x1 is 0, this is 0, and this is 0. So this becomes like this. So minus 1 comma 0, and that is I square. This is a complex number, can be written minus 1 plus I into 0, that is imaginary part is 0, and that can be written as minus 1. So I square equal to minus 1. So after that we will discuss some problems. So for today, that's it. So if you are engineering student and especially from Tigalati Bhagalpur, so you can follow me. Do subscribe the channel. I will cover the previous year question and also the module 1, module 2, and so on for the paper MA 201 that contains complex analysis. That is, we will cover this. So thank you very much. Please subscribe, and if you like it, please share with your friends. So thank you very much. मिलते हैं अगले वीडियो पे. So धन्यवाद.